how is light made? Or in other terms, what is actually light? So in order to answer this question, we got to talk about the photon. And what is a photon? The photon is a particle of light. And since light is energy, we'll simplify things by saying that a photon is any particle of energy. It's a very small particle, okay? And it is emitted into atoms or absorbed. Now, as I finish this video, I will hope to reach the photoelectric effect and hopefully understand it. So, the photon is emitted as an atom has its electrons, of course, and as the electrons move between energy levels, the photons can be emitted or absorbed. Now, what is this? So let's say we have an imaginary atom, and these are the atomic levels, and we have a very heavy, a concentrated nucleus in this direction. And of course, each one of these would complete a complete circle, and the electrons would be rotating in them. Now, each electron has its energy, and this energy is quantized for each level. So if you have two electrons, they on the same level, they both have the same energy, and they have the same frequency. So that's one important thing to understand. But when we move an electron from its energy level to an upper energy level, or when we take this electron from here and we bring it to a lower energy level, well, of course, there's going to be a change in energy. Now, understand, the electron over here has less energy than the electron that's in this energy level. So it has a transfer of energy. Now, how do you bring this transfer of energy? It has to absorb a photon. So you have to let the electron absorb a photon in order to move to a higher energy level. And if it's in the higher energy level and it moves to the one that is below it and beneath it, it will emit a photon. Okay, so going up, you will absorb a photon. The electron will absorb a photon, and going down, the electron will emit a photon to get rid of its excess energy, because the energy level here has higher energy than here. So you're getting down here, you have to get rid of this excess energy in the form of a photon. So energy levels, their energy can be noted by this equation. E, that's the energy in a level, is equal to NhV. And N is basically the number of energy level, and H is Planck's constant, and V is actually, it's the frequency. And that is calculated in hertz. And Planck's constant is 6.625 times 10 power negative 34 joules a second. Okay, joules times second times 10 negative 34. That's unclear. I apologize. And so let's move to a very important. Now, as the electron is jumping from energy level to energy level, it's going to need excess energy, or it's going to leave it. And how do we calculate this energy? Well, this energy is logically called hv. H multiplied, the Planck's constant multiplied by the frequency. Okay, so if the electron jumps from here all the way to here, and we need to find how much energy the photon has to equal in order to move it to an energy level that is above it, it will have to be of this energy, H times V. If it is less than this electron, than this energy, then the electron will completely ignore it. If it is more, it will not ignore it. It will actually transfer into kinetic energy as it is leaving the atom. So let's move on. what is the photoelectric effect? So now that we understand this, we can hopefully understand the photoelectric effect. This is the emission of electrons from the surface of a metal. Now this is big stuff, and it is weird stuff. Now this is like bringing a sheet of metal and introducing light. And you observe that you have electrons that are coming out of this sheet of metal. And so if you connect this as a battery in an electric circuit and you have a lamp, this will actually, and you do the light, well, the lamp will actually work because the electrons will leave the sheet and they will go and activate the lamp. And this is really, really weird. Like, how are the electrons getting out of the metal sheet? Well, of course, classical physics cannot explain this phenomenon because classical physics considers light as waves. And so it doesn't focus on it as a particle as where modern physics actually does. So the metal has very small atoms, and what happens is the light is photons, and the photons are absorbed by the electrons in the outer energy level of the atoms so that they escape. But they have some terms for escape. This is called the critical frequency. So electrons are not emitted from the metal or if there is not a critical frequency. This is called the critical frequency, and this is so important. It is also called the threshold frequency. The minimum frequency required to let the electrons leave. It's called Vc, as in terms of critical. So if the frequency increases, the photon current increases. Okay. So now that we know what a critical frequency is, we understand that in order to find energy, we have to find NHV. Is that right? Correct. But what we can understand as well is that the energy of the photon that is going to make the electron leave has to equal this. It is going to be h, Planck's constant, times the critical frequency. And that is how you know the critical frequency. That is how you find the critical energy of the atom that you are going to have. And so this is the critical energy. This is the least energy of a photon that you could have. That would actually translate to the atom in the outer energy level leaving. Thank you very much, and see you in the next video.